Hello guys, welcome to Code. In this video we will learn about singleton design pattern. So what we will see in this video is what is singleton design pattern and its real life example, different use cases of this pattern and types of singleton pattern. Basically we have two types, eager and the lazy. We will see both of them one by one. Then we will see different ways to implement singleton pattern in Java. Basically we have 5 ways. So we will see each of the way one by one. At the last we will see Java memory representation of singleton object. Basically how this singleton object is getting created in the Java memory. So this we will see at the last. So this is very important and commonly asked interview question. So let's try to move to each of these topic one by one. So what is singleton design pattern? Singleton design pattern is a creational design pattern which ensures that your class has only one instance at a time, right? So if you are having any such requirement where you want that your class will get instantiate single only one time across the application, then you can make your class as a singleton so that only one object of this class will be created, right? So some of the examples of singleton pattern is logger object and connection objects. Let's move to the real life example of singleton pattern which will help you to understand it more better. So in real life, basically what happens in a school or in a college, you will see that there is only one principal at a time, right? So this basically follows the singleton design pattern. Basically if you want to perform any operation through or any operation through the principal position, then you can use that person or you can use the object of principal to execute that operation. And this there will be only single person, so we can say that it will have only single object. So it basically follows a singleton design pattern, right? Hope this is clear. Now let's move to the different use cases of singleton pattern. Here I have listed down some of the very commonly used use cases where we can definitely will be able to apply the singleton pattern. One is logging. So whenever you want to log in your application, you want that instance of this logging object will be shared across the entire application, right? So this logging is basically a very good example of singleton pattern. Then come to configurations. So there are many cases where you are having different configurations and you want to access this configuration. So what you can do is you can write some kind of configuration manager for you, and what you will do is basically you will create only single instance of this configuration manager to provide you the global access across the configuration settings, right? At the end we can have resource management kind of thing. Basically if you are managing any shared resource, something like database connection pools or something, then you want that you will be able to create only single instance or only one instance of this database connection pool, right? So this is the very good example of a singleton pattern. Now let's move to the different ways to implement singleton pattern in Java and how this is getting stored in our Java memory. So to understand this, let's try to move on to the Java code, right? So this I have created one class for you, this connection class. This connection class basically will be a singleton class, right? So in this connection class, what you will see is it is having a private constructor. So if you want to make any class singleton, what the first step for you will be that you need to make its constructor as a private, so that no one will be able to create it object from outside of this class. Now how we will create the object of this class is basically we have different ways to do it, right? So what we will do is we will expose a get instance method which is static. Why we have keeping it static is basically so that this method will be accessible directly through the class name without creating its object, right? In this method basically we will write our logic to create the object of this connection class, which will be a singleton object, right? So here what I am doing is basically I am checking if my object is null or not. First time definitely it will be null, right? So what it will do, it will create a new object, obj is equal to new connection, and it will simply return the obj. right? So that what will happen, second time when you will call this get instance method, it will check if obj is null or not. Second time it will not be null, right? So it will not create, it will not execute this line at it, and it will not create the object of this class, and it will simply return the object which you have created previously in the first call, right? So this is how we are preventing, we are basically preventing the clients of this class to creating a different of objects and returning only single object every time, right? But there is a issue with this approach. What is the issue is basically, if you will see, if multiple threads will call this get instance method, right? So what can happen is, let's assume two threads comes to this line one by one, right? So if they are coming one by one, then it will work. But if two threads will come directly to this line, and both are coming at the same time, both threads are coming at the same time, then both will find that obj is null and both will execute this line, right? So this will basically break our singleton pattern, right? So what we will do, what we can do is, in a second way, basically we need to create this method as a thread save. So here comes our second way to implement singleton pattern in Java, right? So what we will do is, in singleton, in second way, basically we will simply write a get instance method and we will make it synchronized, right? Now this method is synchronized. So what will happen, if two threads will come at the same time, then this synchronized will basically prevent two thread to access this body at the same time. So only one thread will be able to execute this whole body at a time. So it will prevent me to create the different objects. The logic of this method is basically quite similar to the way, similar to the way one, right? We are just make this method as synchronized to achieve the thread safety. There is a performance issue in this method. Basically, what is performance issue is, basically we have made this complete method as a synchronized, right? While if you will see that we need locking, or we need synchronization only for this stuff, not for this thing, right? So what we can do in another way to get the minimal locking, right? So here come thread safety with minimal locking approach to implementing my singleton pattern. Basically what we'll do, we will check if obj is null, then I will write a synchronized block on this connection class, right? In this block only I will create the object. Here basically, for making sure, we are using double checking of object also. First we are checking if object is null, then my thread is basically moving to the synchronized and it is creating the new object. At the end it is returning outside of the synchronized block, right? So this will basically provide me the minimal locking with the thread safety, right? Now let's move to the next way to implement this pattern, right? Next way is basically eager object. The last three approaches which we have just seen are the example of lazy initialization. Here we are creating the eager object. Eager object is basically, we will initialize this object at the time of object declaring, right? So when I am declaring this object, at the time only I have created the object of this. Basically when we are declaring this variable, at the time only I have created the object, right? When now what we will do is, whenever I will receive the get instance, I will simply return this object without checking if object is null or not. But the issue with this approach is, it will always create me an instance whether I will require to create the object of this class or not, right? So this is called eager approach, and all of these three was my lazy approach, right? So till now we have seen four approaches to implement singleton pattern, right? First three was with lazy initialization, last one was eager initialization. First one was with very simple approach. It is just creating object each time. With the next two approaches we have provided thread safety. Now let's move to the another way to implement, which is basically a Java specific. We will use the power of inner classes, right? So for this I have created a separate class to demonstrate. Basically this is db connection. It is just, you can say, another singleton class, right? So here it is having private method, private constructor. Basically private constructor, I have just simply written down this out to make it more understandable. Here it is, the catch is I have created a inner class of this class, right? So what this inner class will do, it will create a final variable which is holding the object of this class. Right, now I have exposed a get instance method in this class, and I am simply returning the inner dot instance. Right, so what will happen when you will load this class? At that time, whenever this inner class will get loaded, it will create the instance of this class. Right, so this is the another way to implement the singleton pattern in Java. Now let's try to run this. Right, so if I will run this, let's assume, let me see here if I have commented or not. It will work, I guess, with eager. Right, so if I will create this, if I will run this, it is basically running, and it will, if you will see the object, right? So let's try to move to this code base once. So what it is creating, it is creating a connection object 1, and it is calling connection dot get instance, connection object 2, connection dot get instance, and I have just simply printed down the connection object. So if you will see connection object, both are pointing to the same memory instance, right? So it means 7b23 ec81. So it means both of these objects are the same one. We have called this method twice, but we are getting the same instance each time, right? Now if I will see the example of last one of this db connection class, then what is happening, I have created two objects, db connection object 1, db connection object 2, and getting the instance to this get instance method. Now if you will see the log lines, so what is happening when I am calling db object dot get instance, so what I am getting is, I will get you the object which is printing from here. Now the instance is getting created first time. So when you are calling this method first time, then only it is getting created, right? And when you are calling it second time, then what is happening, it is just simply going here, I will get you the object created, and it is not calling instance created. It means now this instance is not getting created, it is getting written from the first time when you are created. It is the same instance which is returning, right? Hope this is clear. Now let's move that how this object is getting stored in Java memory. It is very important to understand, right? So I have created a diagram for you. Basically we are having a stack area and heap memory. So let's say this is my singleton class. You can assume that it is a connection.java class, right? So when you are creating an object either by the lazy or either by the eager implementation, it will create a object, it will allocate some memory in the heap memory. Now in the stack area, whenever you will create a new object, it will point to the same instance, right? So whenever you are calling connection object 1, connection object 2, right, both of these statements are basically pointing to the same singleton object, right? So this is how my singleton object is getting stored in Java memory. Hope singleton pattern is clear to you. If you like this video, please hit on the like button and comment. Also do subscribe our channel and press the bell icon to get notified on our latest videos.